All right, so in this example, we're asked to consider the area enclosed by the curve y equals x, y equals e, and the y-axis. So in a lot of these problems, you have to read very carefully to make sure that you're considering the correct area. So we've got the curve y equals x. So I went ahead and drew this for you so you don't have to watch me draw out my axes and everything. We have y equals e, so that's this up here, and then the x-axis. So the area that we're interested in is this area I've outlined in red. All right, so it's not the traditional area that we look at when we're finding integrals, which would be the area under the curve, between the curve and the x-axis. Here we've got a different looking area. All right, it's the area, it's above the curve, but then still below this line y equals e. Okay, so read carefully and make sure that you're considering the correct area. That's important. And so we're asked to evaluate this area in a couple different ways. One, to look at vertical slices, and another way to look at horizontal slices. So part A is asking us just to look at vertical slices. So let's take a look at what one of those slices would look like. All right, so if we take a look at one of these slices, right, that has a width of delta x, right, and the height here is it's not the distance from the x-axis up to the curve. It's the distance between e and the curve. So what we want is actually e minus e to the x, right? So we're taking the distance all the way up to e, but then subtracting away this distance here, which is e to the x. And then what's left over, is the area, is the height of one of the slices within the area that we're interested in. Okay, so, excuse me. So let's look at these again. Let's just look at each slice. So each slice has an area of, okay, it's just basically, they're just little rectangles, right? So it's just the height, which is e minus e to the x times delta x. So now we just need to add up all those little slices, okay? And we are going, and as we take more and more slices, and as n goes to infinity, it just becomes an integral, right? And so we're going to integrate from, now in this case, we've got to go all the way to 1, right? Because we want to find the area between this up to this line y equals e, and that happens to intersect the graph of e to the x at 1, right? When x equals 1, then y is equal to e. So that's where it intersects that line y equals e. So we're going to integrate from 0 up to 1, okay? And then the height of each slice is e minus e to the x. And the width then becomes dx, okay, as n goes to infinity, right? The number of slices between 0 and 1 goes to infinity. We have this infinitesimally small width of dx. All right, so we know how to do this. We are just going to get, when we integrate e is just a constant. So when we integrate e, we get ex. And when we integrate e to the x, we get e to the x. And then we want to evaluate that from 0 to 1. All right, and then we're going to get e times 1 minus e to the 1, and then minus e times 0, so that's just 0, minus e to the 0, which is 1. Okay, so e times 1 is just 1, e to the 1 is e, or sorry, e times 1 is e, and e to the 1 is e, so these just become 0. They'll cancel each other out, and then we have minus a minus e to the 0, which is essentially just 1. So that's our area. Our area is 1. All right, so we did it by vertical slices. Now we want to do the same thing, find the same area, only with horizontal slices. So let's take a look at that. Now, we want to look at, let's take a look at one of those slices. Okay, so I'm just going to draw what one of those little slices looks like. Okay, so this is delta y now, and this distance here, I'm just going to call it x, right? Because it's a distance in the x direction. And if y is equal to e to the x, that means that x is equal to the natural log of y. Okay, so essentially this x is the natural log of y. Natural log of y. Okay, so this one is almost like just integrating the inverse of the function. So let's take a look at each slice. I'll just keep the same format. Each slice has an area of, okay, so the length of the slice is the natural log of y, and the width is delta y. Okay, and then we want to integrate, right? We're going to add up all those slices and just take more and more slices between 1 and e, right? Because we're integrating up to that line y equals e. And we're integrating natural log of y dy now, right? So natural log of y is the length of a slice, dy is the width of the slice. All right, now you remember how to integrate the natural log. Oh, I don't have this memorized, but it's easy enough to do with integration by parts. So I'm just going to say let u equal the natural log of y, so then du is equal to 1 over x dx. And then dv equals dy, which means then that v equals y. All right, so we're going to take u times v, so that's y times the natural log of y, minus the integral of v du. So, oh, I think I used x here instead of y. Let me erase that. So I don't know what I was thinking here, because we're integrating with respect to y. So, yeah, so this is 1 over y dy. Okay, so if I take the integral of v du, I basically have y times 1 over y dy. The y's will cancel, and it's basically the integral of 1. And I'm going to evaluate all of that from 1 to e. I'm taking a little shortcut here. So I get y, natural log of y, minus integral of 1, which is y. And I'm going to evaluate that from 1 to e. All right, we'll just plug some numbers in here and get our answer. So we have e, natural log of e, minus e, and minus, I'm going to evaluate it at 1. We get 1 natural log of 1 minus 1. All right, so natural log of e is 1. So e times natural log of e is just e. So we have e minus e right here. And so that just becomes 0. And then we're going to have minus, and the natural log of 1 is 0. Okay, because e to the 0 is 1. And so this goes away as well. And so then we have minus a minus 1, which becomes plus 1. Right? So we just get 1 again. So that's a good thing. We match. It's always good to check. If you did it 2 different ways and get the same answer, then you know you didn't make a mistake. All right. Well, so the next thing we want to look at is some volume problems. So I'll meet you for the next lecture, or the next video.